Somehow that pencil in my throat, I haven't even picked up the pencil
Okay, first thing I would do is I would take the very last page of the packet, separate it from the staple carefully so you don't lose the folds, and then I would just keep this off to the side. Some of the notes here are the same thing that are in the white packet that I gave you on our first day of class discussion. I just repeated them here just to make it a little bit easier for the homework today. And then a few of the things at the bottom are new. So the notes right here, number 6, 7, and 8, those are newly added, so we haven't seen those before. Today's homework really isn't very different than what you've been doing. It's just adding one little element and then just trying to get you to see how things connect. So, one other thing for today. As I've looked at homework, I'm noticing that many people are doing a really good job of having really good notation. Tonight's homework's a little different in that it's not really necessary to worry too much about the notation. It's more of just a thinking exercise. So don't worry heavily about notation on the blue packet. We'll get back to notation soon enough. Anyway, really same idea as what we've been working on for several packets now. They give you a function. This time it's just a formula. And as I said before, in the white notes, usually on the AP test, if they're asking you to find a limit as x approaches some number, there's likely to be a discontinuity at that number. So this packet is focusing again on those discontinuities. So they give you a formula, and then they ask you to identify where is there a jump, a removable, or a vertical asymptote in this function. Remember, the function is just a long list of xy pairs, and we're looking for where any of these discontinuities might occur. So the first thing to remember from the white notes is that jumps for our class will only occur in piecewise functions. So because this is not a piecewise function, I don't have to do anything but just remember that fact, and there just is not going to be any jumps in this piecewise function. I'm sorry, this function is not piecewise. Question. Okay, with a formula, if I'm trying to find where there's a removable or a vertical asymptote, this item number 6 in the notes I gave you is extremely important. We keep going back to factoring. Factoring a formula will often allow us to see much better how the formula behaves. So that's what I'm going to do now, is factor that out. So again, the notation here is not super critical, but I am factoring f, so it's best to write f of x equals. And now I'll factor the top and the bottom. And really, I'm looking for matching factors, but not necessarily. They don't have to end up matching. This is 3, this is 2. Does anyone need me to do any more explanation of how I got that far? Okay, one other thing about the blue packet is every once in a while I have a homework assignment that lends itself to doing different examples in different classes. So right now I'm recording number 1 as we discuss. This way, that way, in different periods, I can do more examples and post more videos to help you. Just don't ever, again, fall into the trap of just watching the videos and copying what I do. That's not going to help. I just use them to make sure your understanding gets better. And if you need more help, come see me. I've been trying to stay after school as long as I possibly can. Yesterday I was able to stay till 1:30, then I had to go to a meeting. Today I can stay clear till 3:30 if I have to. So from 12:30 to 3:30. But if no one's here, I'm not going to stay that late. I mean, I have to stay till 2:45. But anyway, so if you need help, come after school. So anyway, now I'm going to factor the bottom. So let's see. You end up with x. This is 2 and 3 again. This one's negative, this one's positive. Questions? If you have trouble with factoring, come talk to me after school. I can usually help you get that fixed pretty quick. So, okay, next thing I like to do is I think it really helps to spread things out. So, I look for matching factors. We've got this extra factor in the numerator and an extra factor in the denominator. Questions? Now look at note number 7. It says an x-coordinate which causes the y-coordinate to equal 0 over 0. An x-coordinate which will cause the y-coordinate to equal 0 over 0. We have that occurring because this is the formula for finding all of the y-coordinates. And within that formula, I have a set of matching factors right here. So if I were making a table, a list of all the xy pairs, when I plugged in exactly 3, I would discover this would become 5 here. This would become whatever, but this is the key element. This would become 0 over 0. And 0 over 0 here would make this entire numerator 0. 0 on the bottom would make the entire denominator 0. So the y-coordinate when x equals 3 would become 0 divided by 0. Please.
Why is it 3 and not negative?
How many noticed the mistake? Please raise your hand. Keep your hands up. Keep your hands up. Give yourself 3 points. Give yourself 4. Let's put down 5. And give Jonathan. Yeah, we'll walk to the back. Okay. Sorry about that. Half the brain is asleep myself. I kept talking and it made no sense whatsoever. Other questions? Okay, look at your notes. Make sure you read this. It's a favorite thing to do on the AP test. You factor everything out, and one of the factors ends up being something like this. So you do have a set of matching factors, but there's no x that will make this 0 divided by 0. So this isn't causing a removable discontinuity. So watch out for that. You know, that type of thing. A more common occurrence would be this one. Go to this, hold on. Come on. So here's more common. Don't want the calculator. Stop. With that. E raised to any exponent is never 0. E raised to an exponent is never negative. So this is never going to become 0 over 0 either. So just watch out for little tricks like that. Question? that now. Okay, so we found the removable discontinuity at x equal -3. Vertical asymptote. Look at note number 8. An x-coordinate, which causes the y-coordinate to equal some number divided by 0. That's the x-coordinate location of a vertical asymptote. So, if I were to be working down my list of xy pairs at x equal 2, this is equal to 1 now. 2 plus 3 is 5. 5 divided by 5 would be 1. So this is 1. This is 4. Here it is. 1 over 0. So the top's going to end up being 5 times 4, which is 20. But the bottom's going to be 0. So I have a number divided by 0. That's what causes the vertical asymptote discontinuity to occur.
Does it have to be a non-zero number, like if you have a vertical asymptote at -3?
At x equal -3?
Yeah.
I'm not sure what you meant by non-zero, but yeah. Keep talking about it.
It's when a number over 0 is the x-coordinate, that's the vertical asymptote. Does it have to be a non-zero number, like for the x plus 3 over x plus 3? Wouldn't -3 fit the same thing?
Oh, 2 points for that. Mark them down. You look for, the idea is that if there's a set of factors, so that there's an x-coordinate which will cause 0 divide. I think I know your question. Let's just keep talking. If you get 0 over 0, that's a removable discontinuity, and that prevents, like, it supersedes. Like, so once there's a removable at x equal -3, you could invent a function that would, we're not going to go to quite that difficult of problems for our class. So because this is removable, it's not a vertical asymptote. So exclude that. So I always look for the removable first. If there is a removable, document that, and then look and see if there's also a vertical asymptote. Did that answer your question? Perfect. Here we go. Cool. So the vertical asymptote is at x equal 2. Now it's just a matter of connecting what we've already learned. In previous packets and notes and discussions, we learned this, that a jump occurs when the left and right limits don't match. If the left and right limits do match, but the value of the limit is different than the value of the function, like this, then you have a removable discontinuity. So right here, I know I have a removable at x equal -3. So on the packet where it says what's the limit as x approaches -3, I can find this very quickly now because I've got my formula right here. This is how I find all the xy pairs. And I remember from previous homework that as long as I'm looking for an x value that's not exactly -3, so I'm not looking at x equal -3, I'm looking close, this will equal 1. And really, as long as I'm picking an x value that is not -3, my formula for f can be thought of as being much simpler. It's just x plus 2 divided by x minus 2. So, as will occur all year long, the key is to notice the formula way up here is how we find all the xy pairs. This is the same thing. This formula here, however, is how we can find any xy pair except this one. So you can't use this formula to find what's happening at x equal -3, which we don't need anyway because we know that at x equal -3, the function or the y-coordinate is undefined. Questions? Cool. So to figure out what's happening when x gets close to negative 3, I just use this. Close to negative 3 plus 2 would be very, very close to negative 1. Close to negative 3 plus negative 2 would be very close to negative 5. I've just figured out that as x gets close to negative 3, the y-coordinate will be very close to 1/5. When x is exactly negative 3, the y-coordinate is undefined. That's the removable discontinuity. Question? Anything bothering anyone? Like, if you need me to go back through a logical sequence of thoughts, just ask me. If you're like, I don't really get it, just speak up and tell me you don't get it. We'll talk about it some more. So, please.
I'm completely lost with the vertical asymptote being at 2. Like, I don't know how you got that.
2 points for asking. Are you okay with the factor?
Yeah.
Are you okay with the fact that I can list the factors as 3 separate fractions multiplied?
Yeah.
So that feels good. Cool. All I do then is I start looking at these separate fractions, and I'm trying to find an x that will first, I go looking for the removable first, a value of x which will cause a 0 divided by a 0. And are you okay that we found that?
Yeah.
Perfect. So now I say, okay, I don't need to look at this anymore, because for any x value other than x equal negative 3, this is going to equal 1. And 1 times whatever remains is just going to be whatever remains. So I stop looking here. I go looking for factors in the denominator now, looking for a value of x which will cause the bottom to equal 0. And here I find it. If I have an x value of 2, plug that x in, 2 subtract 2 will be 0 on the bottom. And then when fractions multiply, it's just 0 times 1 times 1. That would still be 0. The top is going to end up being something other than 0. And that's what causes the vertical asymptote. I don't know if that helped or not.
That makes a lot more sense. Thank you.
Perfect. Put yourself down for 2 more. It's a really good question. Anybody else? Solid. We already know this one. That's undefined. This one we know as well, because we learned in the white packet of notes that if we have a vertical asymptote at x equal 2, the limit will be non-existent. I hate when teachers don't leave enough room, so I apologize that that blank is too small. No worries. Questions? Catch you too. Please.
Is there a difference between non-existent and does not exist?
No. I have kind of a bad habit that I like to write D&E because it's shorter. But I noticed on the AP test, they more likely will use the word non-existent. So I've tried to convert.
Okay.
But really no difference.
On the AP test, will they mark you off if you put D&E?
I probably wouldn't put D&E.
Okay.
If you write does not exist, they won't mark it wrong for sure.
Okay.
Good question. 2 points. Okay. Please, Jonathan.
Might be simple, but what's the difference between non-existent?
Mostly, whatever math committee decided, they wanted 2 different words. I can see a subtle difference between the 2, but it's not much. A limit is only defined if technically, or a limit only exists if the left-hand limit and the right-hand limit are the same. A function exists only if you can compute the actual number. I don't know, I go round and round. I'm not sure why they chose to make them different. That's just what they've done. So I just follow the pattern, but 2 points. Anybody else? Cool. F of 2. At the location of a vertical asymptote, the value of the function is also undefined. So. And that's it. Question. Cool. Let's stop this recording, go to a different one. Hello.